Hello everyone, welcome to our next learning activity where we are focused on the lab for learning activity 3. And just as a reminder, in case you missed it, make sure you go to GitHub, open GitHub up, and then within GitHub, you want to pull down the latest learning activity. I did make a minor adjustment to it. So when you get out here, just make sure your current repository is KSUS IML main. Go to repository and do a pull, and then you should be in good shape. Okay, so with that said, once you've got that down, you shouldn't have to. I'm gonna open my workspace. Open workspace for this is once you're in your workspace, you're good to go. This isn't anything you have to worry about on your side. This is just something that I have to do because I'm mixing and matching workspaces. So now that I've got my workspace set up, you should see KSUS IML main. I've got the instructor view here, and that's just for us internal instructors. But for everyone else, you should just have KSUS IML main. We're going to go to control flow, and you'll see that we've got our PDF, our PowerPoint, as well as our notebook, our async notebook. And one thing that will also be available is our sync drills. And I will do a quick review at the end of this lab just to show you what to be on the lookout for, what we're going to do in our sync session drills before our Thursday meeting that we have upcoming in our sync session. All right, and let's go ahead and jump into the async portion here. So go ahead and open up your Python notebook async. All right, let's go ahead and get started with exercise number 1, which is operators. We're going to start with basic assignments, and then we'll move on from assignments to arithmetic, comparison, and logical. So starting off with basic assignments, we'll just create two variables. We're going to create one, and we're going to create a value of 5 for this one, and then we're going to do another one for 6, and then print x and y. And that's it. That's your basic assignment. So what we're doing here is we're taking x, the value of 5, and reading it into x. We're assigning it to x. And then we're taking 6 and assigning it to y. And then we're printing out those. So what we should get on a return is x and y. So we should get 5 and 6 on the output. So that's basic assignment. That's pretty much all there is for that. Increment and decrement, it's a little bit more complicated. We still, not in terms of code, just in terms of the thought process. So let's go ahead and we're going to copy this down, and we'll keep this moving forward here. So what we're going to do here is we're going to do an increment, and then we're going to do a decrement. So you put a plus sign in front of the equal and a negative sign in front of the equal, and then that would signify to Python that you're doing an increment or a decrement. In this case, we're going to do 2 and 2. And then we'll print x and y again, and then I'm going to come back and annotate that. And you're going to see here that we've got 7 and 4 as output, so 5 and 6 is 7 and 4. And what that's doing is, and as I annotate this here, it's going to increment. So what we're doing, the incrementer is incrementing 5, the value of 5 by 2. So what it did is it took 5, added 2 to it, and then made it 7. And then this one is going to be a decrement, and it's going to decrement the value of 6 by 2. And what that does is it takes 2 and removes it from 6 and gives us 4. So that's why you see that value. That's what increment and decrement does. Let's go ahead and move on to multiply, and then you can see what these are all. Again, these are all assignments. These everything under here from basic to increment, decrement, to multiply and divide. These are all under the excuse me. These are all under the assignment operators. So let's go ahead and jump into multiply. And for multiply, we use the multiplication. We're going to keep these both multiplying. So we're going to remove that. It's a asterisk equal. In this case, we're doing a multiplication, and I'm doing it against x and y because I want to show you what it does. Let's run this, and then I'll annotate. So that says 21 and 12. And what that's doing here for the first one is it's actually saying auto multiply 7 by 3. That's what it's doing in plain language. And then what this is doing here is multiplying 4 by 3. 4 by 3. Because remember, we're just keeping a running log of what this x value is just running. So it started out as 5, 6, and then these assignment operators are reading this value back to itself. So every time I print it, it's giving us a new value. I don't have to print it out to a new value. On the second pass, I get 7 and 4, and then it's taking 7 and 4, taking 7 and 4, and we're taking 21 and 12. And then what's happening here is 20, it's taking 7 times 3 and 4 by 3, and then that's what you get is 21 and 12. So, all right. Very cool. Let's go ahead and move on to divide, which is going to be... All right, we're going to take this and we're going to do a slash. So we're going to do slash, slash, and then we're going to run these, and let's do 4. I want to run this by 4 because this is going to actually give us interesting output. So for our final assignment operator, it's going to take 5.25 and 3.0 as the return, because what it's doing is it's doing an auto divide 21 by 4, which is what's giving us that floating point. And then we get this auto divide 12 by 4, which does not, it's still going to be a floating point, but it gives us a whole number here. Okay, so that's what that's doing with the divide, the divisional decrement. So that takes care of all of our assignment operators. All right. One other thing of note that I'll say here is that when you look at the way I'm annotating here, this is what we'd call pseudocode. It's not real code, but it's really good to write things out in terms of pseudocode. That in other words, it's plain language, it's plain spoken language that says, hey, I'm doing this by this, dividing it by that, by making this do something else, and that's a good way to actually use pseudocode, so to speak, to annotate your actual code, your physical code. So anyway, that's just kind of as an FYI, to kind of keep in the back pocket. Okay, now let's move into arithmetic operators. All right, so with this one, we're going to do something a little different. You haven't seen it up to this point because I've been keeping things kind of vanilla in terms of the way we're managing our variables. But I'm going to, for our arithmetic operator, let's get this started with a variable a, and we're going to make that equal to x plus y. And here what we're going to do is I'm going to print a, and let's go ahead and run this. And what I'm doing is I'm taking I'm taking the output from our last finalized output from prior, which is 5.25, and I'm doing an arithmetic operation. I'm taking x and I'm adding it to y. So I'm taking 5.25 and adding it to 3.0, and then I'm assigning that output to the value of a, to the variable a, and then I'm printing the variable a, which gives us 8.25. That gives us the arithmetic operator. That's it. It's actually an arithmetic operation that then does an assignment. So we're using arithmetic and an assignment operator at the same time. Now, what I want to show you is that to kind of save ourselves some time on code and make it more compactified, I'm going to write all of our arithmetic operators out on the same, our variable assignments, I'm going to write them out all on the same line. So there's a really neat feature within Python that allows us to do it. We just need to use a semicolon. And what we're going to do now is I'm going to write the subtraction out as s equal to x minus y. And then what we'll do is we'll say s. And this is kind of nice because what I can do is I can run all my variables on one line and instead of taking up multiple lines. So it's a nice, neat little trick to kind of for variable management within your code, but also to kind of keep it more compact. So let's keep it moving. This is pretty straightforward. So we're essentially, we just took x minus y. That's the subtraction arithmetic operator. Assign it to value. Assign it to variable s, and then we're good to go. All right. Next up, we're gonna take multiply, and in this case, we're gonna do d equal to x times y. And let's go ahead and wrap this up. Let's just finish this up and do the division also. And we'll do f equal to x divided by y. All right. And then in our print statement, we'll do d and f. D and f. All right. Let's go ahead and run this. And that takes care of addition, subtraction, multiplication, and division. All right here. So all of our arithmetic operators that we're going to cover for now. And again, there's some that we'll cover down the road. There's potential for us to use some others down the road, but for the most part, we're going to be sticking to this kind of stuff here. Okay, now let's put a little annotation here that this is nice shorthand hand method for variable setup. All right, there you go. Okay, so this is a really nice way to do that. Another thing I'm gonna do is we've kind of taken care of the arithmetic operators. I'm gonna copy this down because this is gonna actually save me some time for comparison operators. I'm gonna instead here though, I'm gonna use C. I'm gonna do C VBN. I just want to create a series of letters that are separate from the ones we used for the arithmetic operator. And then what we'll do is we'll say C V B N. And then, okay, so this is going to help us get set up. So for the equivalency, this is where going to check for equal. This is where I'm going to check for not equal. So this is a not equal. And then over here, I'm going to test for greater than. And here, I'm going to test for less than. All right, that's going to save me some time in typing, and you as well. All right. So let's run this and see what we get. Okay, so when we do comparison operators, this execution, so C equal to X equal Y, what we're doing is we're checking the output of X, we're checking the value and the type. So we're checking to see if X is equivalent to Y, and if it is, then we'd say true. But X is not equivalent to Y, so that makes it false. And so when we talk about comparison operators, their outputs are always Boolean in nature, or they're always true and false in nature. So 0 and 1 is what we get out of these, but the return is false and true, or true and false. Same thing, let's take a look at V. So we're looking at X not equal to Y, and that is true because if we look at the last version of what we got for X, which is up here, this is the last assignment. So up here, this is the divide up here is the last assignment value that was added to X and Y. So in other words, this, let's see, 1, 2, 3, 4, this value right here, that's what we're checking for in this comparison operator. So X is not equal to Y, 5.25 is not equal to 3.0, so that comes out to false. X not equal to Y, that's true, so that's going to come out to true. Now we're going to check on B, which is X. We're writing out the comparison, the equivalency check between is X greater than Y is X. And that's true because 5.25 is greater than 3.0. On the flip side, X is, we're checking for is, you got to think of it, it's a question. Is X less than Y? And then that would be false because it is not. So that's why that returns. So that's what comparison operators are used for, and they're very useful. They're very, very helpful. Make life a lot easier for us. Next up, we have logical operators, and this will wrap up our operator conversation. Again, there's 39 documented Python operators, and we're covering just a fraction of those. We're only covering about about 15-ish percent, 20-ish percent, something like that. So there's more that is available out there for us to go research. I'm gonna actually post a link that I like here after we wrap up logical operators, so you can have that in your back pocket if you want to research more on all the different operators and what they do. Okay, so let's finish up logical operators. And in this one, I only want to show you the and the or. So I'm going to set this up as a u equal to x equal y. And then and x, let's see, bang equal y. So it's we could say exclamation point equal, or sometimes we'll say bang. That's an old school, so we'll say bang equal, or and that's kind of a, or just, and if you want shorthand, you can say not equal. That's what we're saying there. Now, on this, what we're going to do is do a print u. We're going to print u, and then run that, and our very last, it's false. So the reason why this is the case is because the way you can kind of view this, you don't have to do it this way, but if you wrap these in parentheses, this is what we're checking. We're actually checking all of this in the parentheses here. And then we're taking that operation and assigning it to u, and we're checking that. So what we're doing is the logical operator is saying that that essentially that's saying false. The reason is, and that it returns true if both statements are true, and that's the case here. So if these are both true, then we get a true, but one of these is false. So that's the case, right? X is not equivalent to y, so that's false. But x it is not equal to y, that's true, and so then that returns a false. So they have to both be true to return a true. Now, but the other thing you can do is the reverse. You can say they can both, if you're checking for both of them to be false, that can return a true also. So you can be checking for that as well. So it's not just always looking for trues. You can actually reverse the logic and say I'm looking for falses also, and still get the same output. It just depends on what you're trying to do. But for us, just kind of know that that's what and is looking for. Next up, I want to write this out on a separate line and not on the same line, just for clarity here. I'm going to create another variable called I, and in this case, I'm going to do an or, and I'm going to do this with let's do this. I'm going to say greater than, and then I'm going to say less than. And let's run this. Print u and I. Like this. All right, and run this. Okay, so I'm going to get a false and a true on this case. So if we analyze this, and again, I go back to annotating the code here, returns true if one is true. All right. Now, when you, whoops, where did my code go? There we go. All right. So the reason that one call comes out as true here for this second execution, this one right here, is that one of these, only one of them has to be true, not both of them. So x is greater than y. Is it? That's true. X is greater than y. But x is not less than y, but it doesn't matter because at least one of these is true, which makes that work. So that makes this come out to true. Okay, you can actually stack these as well in terms of you can do multiple ors, or you can do and ors. You can kind of make the logic a little bit more complicated too if you need to, just depending on what you're building or what you're trying to do. So that's all I've got for operators. I did promise a link, so let me go grab that link for you. Okay, so here is that link. If you want to learn more, I'm going to put a string literal up here. You can. I've got this that I pulled from my presentation. This is a good website here. And you can go out here to this website and get quite a bit more information. Highly encouraged to go check out more as it relates to operators again, because you can get a feel for how rich the operator set is and the operator features are within the Python programming language. All right. Okay, so let's we've got that knocked out. Let's go jump over to I'm gonna minimize that. We'll go over to control flow, and we'll talk about sequential, selective, repetitive, and then repetitive with nested flow. So first up, let's do the simple one, sequential flow. So I'm going to revisit hello world, and we're going to do something simple. Hello, and then b equal to world. And then we're going to do a print a 8 plus b, and then we're going to run this. And so you're going to be like, wow, we did this like 5 times already. But we have to understand the context from the basic, because the basics here are showing us something else as well. So a sequential flow says that this is what's happening. Step 1 is occurring, then step 2 is occurring, and then step 3 is occurring. Again, most programming languages work in this top-down fashion, where you do one, then the other, then next, and it has this sequential flow. So this is the basics of a sequential flow, and let's move on to the next one. Okay, so for selective flow, we've got let's put this is the if else. Pretty much that's what we're talking about here. This is let's just get this if else, and then there we go. That's plenty. Okay, so we're going to create a print statement, and let's create 4 variables, or 3 variables rather, y, x, y, and z. Y is 24, and then z is equal to 67. All right, and then let's do an if y is greater than z, or x, sorry, if y is greater than x. Then we're going to do a print statement that says that exactly what we're requesting it to do, which is y is greater than x. And then after that, we'll do an else if. We'll do an else if. There we go. And x equals z. Then we're going to print x and z. Sorry, x and z are equal. Again, we're printing out exactly what we're requesting in the command structure that we're building here. And last up, we're going to do an else. We'll do an else statement, and we'll just say print x. We'll just say x is greater than y. Okay. So this is what's called selective flow, and we're actually controlling the flow in 2 ways. One is we're controlling it with this control flow here, but we're also controlling it with the variables that get passed into it. So there's 2 mechanisms that are controlling to a certain extent. So you can kind of think of it that way too. But yeah, this is our command structure that is going to execute a given block of code for a given set of sequence of numbers. So let's see what happens. So if I run this, we show that x is greater than y, which means that our first branch did not execute. So if y is greater than x, that didn't fire. Else if x is equal to z, in other words, x and z are equal, then that would fire, but it didn't. So that didn't fire either, which means that it defaulted to the final, which is x is greater than y. Now, this is a very rudimentary. We'd probably put a lot more structure into this to make this more clean, but let's just double check our numbers to make sure it's right. So x is greater than y is what it defaulted to, and x is greater than y up here. So it defaulted the right way, but it wasn't a really clean way that it did it. So to make it clean, what's really nice about selective flow, or it really just most programming languages, but Python's kind of nice about this, is I can actually create another branching structure in this. It doesn't have to fall in this way. So I can create another else if in this. And let's say I want to make it more clean. I want to make it nice and precise. So in other words, I want to make sure that I'm not just defaulting to this, but I'm actually doing exactly what's required to get the right output. So in other words, I'm looking for x greater than y, and then I'm going to put this x is greater than y up here, and then I'm going to put this, oops, right there, and I'm going to highlight this and paste that in, x is greater than y, which is exactly what we're asking it to do. And then I'm going to default this to unknown, just for now. Okay. And so what this is going to do, theoretically, based on the parameters that we've passed it, I got an if, and then an else if, and then another else if. And so I've got this structure that theoretically could go on for a while, but it should exit at this point. It should print x is greater than y because that is true. And I should get a clean x is greater than y here. So let's run that, and that's true. So I get a x is greater than y, and that's exactly what we're expecting. So yeah, so that works out just like it's intended. And you could put in test. I was goofing around with it just a second ago. So you could put test in the unknown, or you could do something like that as well. But that should work. I think that's all I have for selective flow. Now let's move over to repetitive flow, and let's look at what we can do here. So now on repetitive flow, I'm going to do a while loop. Let's put this in while loop, and let's do this. There we go. Okay, so for the while loop, I'm going to do a print, and we'll just do a print statement there, so it's nice and clean. Okay. Here I'm gonna start with an iterator, or in this case a variable that I'm gonna iterate on in a while loop, and I'm gonna start with 3 just for kicks. So I'm gonna create the while loop is while I is less than 15. So and then what I'm gonna do is I'm gonna use an operator to increment the value of I. So I'm gonna say I plus equal 3. And then I'm going to say else. Come on, wake up. There we go. Else print I is no longer less than, and I'm going to make this programmatic. I don't want to keep typing it out each time, so I'm gonna print the actual value of I as we go through the loop. After this, we'll do the for loop, but right now we're working on just this while loop. So this while structure right here is pretty standard, but every keyword, so the while, every conditional part of this, or a branching component of the flow, the control flow, has this this colon on it. And so this colon has to be added. You may have noticed that earlier, like, why is this colon getting added? So any branching component or any conditional check within the within your control flow has to have that colon, because that designates the beginning of a code block in this case. So, all right, and it has to be indented. So you can't pre-dent this, and I'll show you what I mean here in just a minute. So let's run this and see what happens. Okay, so my while loop successfully executes. I is no longer than 15. So let's talk through the execution here. I equals to 3 is where we started, and then I incremented it each time I pass through the loop. So what we're saying is while I is less than 15, right? So we're using a comparison operator and then an incrementer to increment i's value as we pass each time through the while loop. it goes and increments it by 3. So we get 4 passes in before we exceed that I is no longer less than 15, and it ends at that point. So we get 3, 6, 9, 12. Now, if I had taken the same thing and I changed it to 2, and then I rerun this, we get 3, 5, 7, 9, 11, 13, which means that I get 6 iterations through the loop because I'm keeping my incrementer at a smaller value each time I pass through the loop, which means that I'm able to pass more through the while loop before exiting the while loop. So that's one of the things to keep in mind in terms of how to structure a while loop. There's lots of different ways you can make these and construct them and nest them, but this is a basic one. That's a good way to get you started. Okay, next up we have a for loop. For loops are pretty straightforward. This is let's put a print, and then for loop, and like this. All right, and then make sure that that is a string literal. Okay, all right. So let's create a string, and then just to show you, we can actually iterate on strings too. They're iterable objects. So I'm gonna say my string, and then what I'm gonna do is create this for loop. So I'm gonna say for x in string, and then print x, and then I'm gonna print. Oops, I'm gonna hold off on that. This is it. That's all. That's for loops are super simple. They're simple, repetitive flow structures and super helpful. For loops are really cool. The for loop is in this case is going to run on an iterable object, which is the string, and then it's going to, so in this case this is for. So I take the string and then I pass it into the variable x on each. So each pass of the values that are here get read into x, and then I just print each value individually. So this being an iterable object, it goes through and iterates on each individual position of the string. So M is the first position, Y is the second, the space is the third. That's why you see in this third space that there's a space in the iteration. And it does this till completion. So it finds the total length of it and then goes all the way to the end. One of the things you want to be careful with in terms of repetitive structures is making sure you don't create any infinities, which can happen. So for example, you can create for loops that never end because you have no conditional breaks. In this case, there's a conditional break because it's predicated on the string's length. So as the string, as we run out of data for the for loop to iterate on, it ends as the length of the string ends. Same with the while loop rather. We put a conditional break on here that says that it's going to exit in terms of it will never go over 15. So we made sure that we put a conditional break on that it won't exceed 15, and therefore it ends. But if we could actually create conditions that never hit. And then you can get while loops or repetitive loops that run forever and never end, which can create memory problems. So those are one of the things you do have to be on the lookout for when you work with repetitive flow structures. Okay, let's see. I think we've got one more, which is a for loop with if and break statements. So this is that last one. All right, print. Let's do a print statement. And and then we'll say, oops, I did it again. There we go. Okay, so we're going to do a for loop with if and break statement, with if and break control. Let's just say that. All right, and then here what we're going to do is I'm going to create a list called fruits. So let's say fruits equal to, and in this case I'm going to create like that. Yep, and then let's call this apple And this is a data structure that's called the list data structure. And you saw a version of this earlier when we were talking about data types. Okay, and so in that data type conversation, in that learning activity, we work with lists, we work with tuples, we work with sets, we work with dictionaries. But in this case, we're just creating a fruit object called fruits that contains apple, banana, cherry. Let's go with lime, and then coconut. Perfect. And so if we run this, we're not going to get anything when we run it just like this. We just get the for loop print, but we don't get the fruits because we didn't print the fruits. But if we just print the fruits, or if we just type in fruits in Jupyter notebooks, you can get away with doing this. If you're in a traditional IDE, you can't get away with that. But let's stick to our guns here. Okay, so print fruits, and then you get apple, banana, cherry, lime, coconut, and that's great. But now let's do this. Let's talk through this repetitive nested this nested selective flow that has a repetitive flow outside of it. And let's go with a for loop because they're pretty straightforward. So I'm going to do a for x in fruits. In other words, I want to iterate on the fruits list, and on each iteration, I'm going to pass that into x. And then that x is going to get passed in where I can evaluate it. So then in this case, I'm going to evaluate it to be lime. So I'm going to create an if statement. If it hits lime, I'm going to create a break. In this case, when it hits lime, it stops, and then it ends. So I'm going to put a print statement just to capture the x, to capture the individual elements of the list as they're passed through the for loop. Okay, so I'm going to run this, and then what we'll get is apple, banana, cherry. And that's exactly right, because when we hit, when x finds an equivalence of lime, it breaks, and then it breaks the control flow. And that's exactly what we're looking to do. So it iterated on the list 3 times before exiting. Now we can test this by doing coconut. We can say coconut, and then go here, and then we'll get apple, banana, cherry, lime, which means that at the point where the equivalency check happens, where x equals to coconut, then that means that our for loop, our repetitive control structure, ends because we have a nested selective flow within it that says end. So that's helpful for us because it gives us a lot of control, and we can do for loops. We could do for within fors. We can do whiles within fors. We can do nested. I mean, that's why I say this is a mixed flow situation here, like I was talking about in the lecture. What's really nice about this is, again, you have a lot of power. And most of the time, it's rare for us to create programs that are just strictly repetitive or strictly just selective or strictly sequential. Most of the time we create flow structures that control flow structures that look like this in programming languages. All right, I think the one thing that I need to show here is I do want to show one more thing. So if I want to create a, I'm going to go back to the original. One thing is that case sensitivity is very easy to illustrate here. If I put this uppercase L, you can kind of take bets on what you think is going to happen. Well, because X never encounters a lime, although we have lime in the data set, but it's not equivalent. It's not going to hit an equivalent check. It's not going to roll true. It's going to roll false if in this case, which won't execute the break. So if I run this, it's going to actually run through the whole list. And the reason for that is because these are considered 2 different data entities. Lowercase, this lime is not the same as this lime. And Python is very strict in this. It's case sensitive. But it's also, again, these are not going to be viewed as equivalent data items. Now, if I came in here and said lime like this, and I was explicit and made this uppercase, then what's going to happen is
we're going to get apple, banana, cherry, lime. Even though we have two limes in here, they are looked at as two distinct separate entities. So that's one thing to keep in mind. Um, and loops are really good at at finding those, spotting those issues. So when you create repetitive control structures, you want to create an ability to debug. So it's very important. Like what I did here is I printed the fruits out, and then I also printed the output of the control structure for every for loop so that I could compare, here's what's in the list, and here's what the output was as we rolled through the for loop. So from a debug perspective, these are really helpful little tips and tricks to kind of keep in mind. With that, that is all I have for the lab. Next up, what I want you to do is I want you to try this out. I want you to create a for loop that loops through the following list. Instead of a list of fruits, this is a list of cars. And essentially, I just want you to get in the practice of creating your own Python code. So here's a simple one for you. You have everything you need here to make that happen. So create a for loop and then print your output. And with that, that's all I've got for now. And I will see you later this week.